So, today we shall discuss about current source or sink. Now, if you recall from your knowledge of basic circuit theory, then a current source delivers current to a circuit. An ideal current source is supposed to deliver a constant current to a circuit irrespective of the voltage across it. Therefore, the IV characteristics of an ideal current source is going to be like this. The current at the output of the current source is constant and is independent of the voltage across it. So, now if you take del I del V, that is equal to 0, which implies del V del I equal to infinity, which means that the current source has got infinite output resistance. So, an ideal current source should have infinite output resistance. In reality, a current source deviates considerably from this ideal behavior, and the IV characteristics of a real current source is somewhat like this, where you can see that there is a departure from the constant value of the current as you go on increasing the voltage across the current source, and a real current source is modeled by a high impedance in shunt with the ideal current source. Now, coming to the current source or sink that is designed using a MOS transistor. So, this is the ID versus VDS characteristics for a MOS transistor, and therefore, you can see that this part of the characteristics is nearly flat. So, beyond the saturation region, we can see that ID hardly changes with change in VDS. So, the boundary condition is VGS must be greater than VT and VDS must be greater than VGS minus VT. So, under such circumstances, you can write ID equal to mu n CoX W by L into VGS minus VT whole square into 1 plus lambda VDS, where lambda is the channel length modulation index, this is 2L. So, we can find that del ID del VDS equal to lambda mu n CoX W by 2L into VGS minus VT whole square now, which is approximately equal to lambda ID. Now, lambda is very small, which is 0.04 per volt for an NMOS transistor and 0.05 per volt for a PMOS transistor, and therefore, this quantity is nearly equal to 0, which means that del VDS del ID approaches infinity, and therefore, at least mathematically we can see that a MOS transistor can be used as a current source or sink. So, now if you consider a MOS transistor, if you bias this MOS transistor in the saturation region, then you can use it as a current sink. One of the things you have to ensure that this MOS transistor must be biased in the saturation region. Similarly, you can use a PMOS transistor biased in the saturation region as a current source, and you connect it to a circuit. The difference between current source and sink is that while a current sink is the place where a current comes and terminates, current source is the element from which the current originates and is delivered to the other components in the circuit. Now, if you see the small signal model of the current source or sink, then you can see that at the since this device operates in the saturation region and we assume that source and bulk are shorted, therefore, we can ignore GMBS. However, GM is going to stay, sorry, GM is also not going to stay, only RDS is going to stay. So, this RDS actually gives a measure of the output resistance of the current source, and greater the value of this RDS, the better current source it is. So, it is highly required that this RDS is as high as possible. So, the greater the value of RDS, the better current source or sink it is. You can also think of connecting a number of such current sources and sinks in cascade. The advantage of such cascade connection is that it leads to an increase in the value of the output resistance and makes it a better current source or sink.